I think Shada, we can start. I'll make you the host.
Okay, thank you.
Okay.
Okay. I'm going to start by carrying on with the electricity first of all, though, okay, right? But you give me two topics there now to do with future lessons, okay? Circular motion and waves and sound, okay? We all okay with that? Kabiro, yeah? Okay. Okay, I'm going to share my screen now then, everybody. And I'm going to remind you of the electricity we did last time. So, you have a battery, which I'm going to turn on like that now, with a wire going there. I put a switch in the circuit. I'm going to put a resistor in my circuit. And I'm going to have my wire here. There. So there. And at the moment, there's no electricity flowing because it's not a complete circuit. Okay, right? It's not a complete circuit. When I switch on, there'll be a current flowing around that circuit only like last time. Okay? So I got a complete circuit there now. Now I can put a voltmeter across here to measure the voltage. So I'm going to connect this across here. So I'm going to put that there. I'm going to put that there. I can't read that at the moment. So that reads 9 volts. So it's obviously a 9-volt battery. Wherever I put this, it's going to read 9 volts. So that's the voltage of the battery. Oops. There reads 9 volts. There is reading 9 volts. So that's the voltage across there. Now then, if I want to measure the current, I've got to put the ammeter in the circuit. So I'm going to get rid of this here, put the ammeter in the circuit, and the ammeter will measure the amount of current flowing in the circuit. Like that. I'm going to switch off for a minute. And the voltmeter will measure the voltage across whatever I've got. In this case, I have got a resistor. It'll measure the voltage across there. They're both reading 0 at the moment because I haven't completed the circuit. So when I switch on, it gives me a reading of voltage of 9 volts and a current of 0.9 of an amp. If I convert it to that sort of circuit, then it's showing like an old-fashioned resistor there with the cell, isn't it? Okay. Same thing, it's just another way of looking at it. So I go to that and I've got that there. So I've got 9 volts and 0.9 of an amp. Now then, I know from last time, if I click on that, right, it's a 10 ohm resistor. But 9 volts divided by 0.9 will give me 10 ohms. R is V over I. Now then, if I put another resistor in here, in series, I'm increasing the resistance. So if I do that now, oops, I'll switch off first. If I switch off there and do that, okay, and I'm going to take the voltmeter out. I'm only going to look at the current now, okay? So I'm going to get rid of my voltmeter for the moment. Right there. And I'm going to switch on. So if we look at that then, okay, the current has got less, it's got halved. Why? I doubled the resistance. So these are two resistors in series. So, okay, if I stop my share there now then, and go to my board like I did last time. So I got my pen there. Okay. So what have I got? I've got a cell, which is 9 volts. I had a switch, and then I had two resistors in series like this. That was 10 ohms, and that was 10 ohms. So when I switch on, electricity is going to flow around this circuit like that to there. I want to find one resistor that has the same effect as those two, but when they're in series, all we do is add them up. So the effective resistance of those two, right, would be 20 ohms, because it would be 10 plus 10. Now then, if I want to work out the current flowing here, the current by Ohm's law, like we did last time, would be V over I. So it would be 9 divided by 20, which works out to be 0.45. That's what the multimeter was, the ammeter was reading 0.45 of an amp. So what happened when I put an extra resistor in, I doubled the resistance, I halved the current. It's basically saying here V to I, or V equal to I. So if the resistance goes up, current goes down for the same voltage. Notice I didn't change the voltage, kept it at 9 volts. Now what changes is when we have resistors in parallel. So if I look at this one, if I show it like down here, if I have two resistors in parallel, I'm going to say they're both 10 ohm resistors, and I want to find one resistor that has the same effect as those two, RT. I use this formula we used last time. 1 over RT is equal to 1 over R1 plus 1 over R2. In my example, it's 1 over 10. It's 1 over 10. It gives me 2 over 10, which is 1 over 5. So 1 over RT is 1 over 5. So the equivalent resistance there is 5. So in this situation, when we put them in parallel, the resistance is less. In this case, it halves. When we put them in series, the resistance is more. And this is what we were doing last time, wasn't it? Okay, working out the resistance in parallel, working in series. So I'm going to ask you now, just as a quick reminder, okay, to go with these two questions. Have a go at A and B, okay? I just want you to work out the resistance of those two there, A and B. One's in series and one's in parallel, okay? So I want you to work out the equivalent resistance of these two networks, okay? I'll give you a few minutes to copy them down to have a go at it, and then I'll see how you get on. So A and B, as you can see on the screen, what's the resistance of those two circuits? The combined resistance. So it's a 200 and 400 in series, and it's a 400 and 200 in parallel, okay? Make sure you got the circuits down, because I'll be putting them on my board in a minute, okay, right? So it's a 402 in series and a 400 in parallel. When you've got answers, you'll be able to show me like we did last time. But make sure you get your name so I can remember your names and so on. And take it down now, okay? So I can see how everybody's getting on. If you've got answers, you can show me, okay? So A was 400 and 200 in series. B was 400 and 200 in parallel, okay? Do you want me to put the questions back up? You want me to put the questions back up? Yeah, okay, I'll do it. And take them down now, okay? See how we... Has anybody got any answers? No? Zero? No, not happy. Okay, well, St. Mary's? Okay, I'll wait, okay. Waimuni? Are we okay? Or Waimuni? Okay, fine. Matari? You're okay with it? I'll wait a minute and then I'll go through it then, okay? Just to see if anybody's got any answers. Okay, I'm going to pin St. Mary's. Hang on a second. Um, I can't quite see it, sorry. 400 and 200. Yeah, where's the resistance? So I can't see it. Sorry, I can see your diagram. Uh, I see what you've done. Yeah, what's your name again? Sorry, can you put your name on it? I'll be there in a minute, my Mooney. Oh, Zahura Mohammed. Is it Zahura Moham? Okay, Zahura Mohammed. Yeah, thank you, Zahura. Sorry, my pronunciation's rubbish, but thank you. Okay, I'm gonna go to Waimuni. Waimuni. Let me have a look. Omanga, I'm looking now. Bear with me. I'm looking now. Put it up again. Yeah, one of them is right. That is, yeah, that's right. Omanga, yeah, good. Okay, I'm gonna go now then. Oh, hang on. So Waimuni, I'm going again. Bear with me. Put it up again, Waimuni. Can you put it up again, Waimuni? You put it up. I can't see it again. Yeah, who's that? Okay. Waifula? Yeah, that's right. Waifula? I'm not saying it right, am I? Sorry. Okay, sorry. Okay, right. Who else? Oh, hang on, St. Mary's. I'm going to look again. Bear with me. I'm looking at St. Mary's. I'm trying to pin you now. Hang on. Oh, yeah. Okay, Newton's laws, is it? Okay. Give me a second. Let's finish with this first, okay, right? I'll do that at the end, St. Mary's, okay, right? I'll do the question at the end. Okay, let's go to my screen now then. I think you're all a bit, or some of you know and some of you don't, okay? So, in this question I gave you, what you had was a resistor, like this, first of all. They were in series. One was 200 ohms and one was 400 ohms. And we want to find one resistor that replaces both of those. This was A, okay? This is the first one. All we do in that is add the 400 to the 600, to the 400 rather, to the 200. Give me an answer of 600 ohms. Can't write this properly. Let me start doing that tidying up. Sorry. Okay. So you add them up and it becomes 600 ohms. So the total resistance of those two placed in series, you just add them up. 400 plus 200 gives you 600. Now then, when they're in parallel, it's different. It's more difficult. What you've got now is this. You've got your, I'll say the 400s there, ohms, and here you've got your 200 ohms. Now then, to find one resistor that has the same effect of those two, I call RT, R total, we use this formula. 1 over RT will be 1 over 400 plus 1 over 200. So what I do now, I bring them over a common denominator, and they both go into 400. 400 goes into 400 once. 1 times 1 is 1. Plus 200 goes into 400 twice. 2 times 1 is 2. So what I end up with here is 3 over 400. So 1 over RT is 3 over 400. So RT will be 400 over 3, which works out to be 133.3 ohms. So when you place them in parallel, the resistance gets less. It behaves like a 133.3 ohm resistor. When you place them in series, its resistance gets more. It behaves like a 600 ohm resistor. So all you do when they're in series is add them up, R1 plus R2. It's more difficult when they're in parallel because what you do 1 over one of them, R1 plus 1 over R2. I'm going to give you one more to do now then, okay, right? Just to remind you. So, let's have one more. Have a go at this one. Oh, I'll start again. Wait. Okay. So I'm going to say that there is a 6 ohm. I'm going to say that there is a 3 ohm. One resistor that has the same effect as that. I want you to work out the total resistance of those two. It's very similar to the one on this Bible. We're finding the equivalent resistance, okay, right? And this is when they're in parallel. So we can use the formula 1 over RT is going to be 1 over 1 plus 1 over R2. Just as I did over here. So have a go at that question now and call this one C. Okay, I'm gonna have a look now. I can see some people putting answers up. I'm gonna have a look now then. Let's have a look there then. I'm going to Waimuni. Okay, put it up. I can't see. Go on again. I can't see it, sorry. It's light. And again, bring it closer to the camera. Waimuni, closer to the camera. and down. Oh, well, stop, stop, stop. Oh, I can't see it. Yeah, Margaret, that's right. Good, that's right. Well done, Margaret. Good. Yeah, good. Well done, Why Mooney. Anybody else got an answer for me there now then, please? Okay, I'm going to St. Mary's. Let's have a look there. Ah, no, you don't add the 6 and the 3. Okay, you can't add the 6 and the 3. Right? I'll go back to my screen. You don't add the 1/6 and the 1/3. I'll go to my screen now just to make sure again. Oh, hang on. Why, Mooney, you got another answer? Okay. I'm going to draw it here now again, right? Okay. So we had a 6 ohm resistor and we had a 3 ohm resistor. And we want one resistor to replace those two that I always call RT. So I use this formula, 1/RT will be 1/one of them plus 1/the other. So it's going to be 1/6 plus 1/3. Now then, you don't add the 3 and the 6, okay, right? You don't add them. You bring them over a common denominator. Both of them go into 6. 3 goes into 1. So this 6 and a 6 is once. 1 is 1. 3 goes into 6 twice, times that, 2. So I'm left with here 2, 3, 1, is obviously 1/2. So our total would be the inverse. You flip them round. So you flip these two round. So R2 there is 2 ohms. If you don't like doing it this way, right, I'm going to show you another way now, which I didn't do last time. I'm going to write over here. We can work this out, right, just by doing this. Watch what I do now. I multiply the 6 by the 3, and I divide by the 6 plus the 3. In other words, I take the two numbers, and I multiply them out, and I divide by their sum. So 6 times 3 is 18. 6 and 3 is 9. 9 into 18 goes twice. 2 ohms. Sometimes that's a quicker way of doing it. You just multiply them out and you divide what they add up to. And you don't have to worry about doing all this then, okay? Some people prefer this. Some people do it that way. It doesn't matter which way. But this thing here only works with 2 resistors in parallel. If there are more than 2, it doesn't work. I'll do another one now. Both ways, okay, right? I'm going to do another one both ways so we get it clear. Oh, hang on, St. Mary's, you're showing me here. Hang on a second, I'll look now. I'm looking now. I can't read that. Give what? Sorry, give. I can't say it. Give me. I can't read it. Go down a bit. Give me. St. Mary's, move it down. I can't read it. Give me another. Okay. Another. Okay, we'll do another one. Okay. One more. I'll give you another one now then. Okay. Right. So one more then, and then I'll go through one again then. So we're going to have this now then, okay? 2 resistors in parallel. And I'm going to say this is a 9 ohm resistor. And I'm going to say that there is an 18 ohm resistor. Okay? And we want to find one resistor. It's more difficult, this one, I think, that replaces them both. Okay, right? I've deliberately chosen 2 numbers there now, 9 and 18. Okay, I'm choosing them because they should go into each other. Okay, and the formula we've got is 1/R total will be 1/R1 plus 1/R2. and we bring them over a common denominator, don't we? Are we with it now? Okay, I'm going to see somebody's got an answer there. I'm going to stop there. Why Mooney? Give me a second again. I'm looking now. Why Mooney? Margaret. Yeah, that's right, Margaret. Good. Yeah. 6. Good. Well done. You've got it. You've got it. I know. I can see. Just want to make sure everybody's got the ideas. Yeah. Kabiro, are we okay, Kabiro? Matari? Can you give me that, or that? Kabiro, you're getting better. Matari, you're okay. Right, okay. I'll go back to my question in a minute and St. Mary's. I've had to go. Have a look now then. Let's have a look then. St. Mary's, I'm looking now. Move it up a little bit. Go, I can't quite see it. I can't see it. I can see the other answer. Go down a bit. Up, move it up, up. Yeah, yeah, that's right. Well done, St. Mary's. Yeah, what's your name again? Sorry. Keep your name on it. Oh, yes, Suhuna. Sorry, yeah. Thank you, Suhuna. Yeah, good. Thank you. Right, okay. Just to make sure, I'm gonna do it once more. I'm gonna go through the example both ways, okay, right? So, what do we got? We have got two resistors, a 9 ohm and an 18 ohm resistor. And we want to find one resistor. Oh, Kabiro, hang on, Kabiro. You can't quite see it. Move it back from the screen a bit, Kabiro. I can't see it. Move it back from the screen, Kabiro. It's too close, too close. Oh, hang on. No, no, that's not right. You don't add the 18 and the 1. Sorry, that's not right. No. 18 and 9, you divide by 18 and 9, okay? I'll do it in a minute. Now, you see what you've done, Kabiro, okay? So going to my board here now. I do it both ways, Kabiro, okay? So we got two resistors in parallel, like this. And that was 9 ohms, and that was 18 ohms. And we're trying to find one resistor that has the same effect of them both. I'm going to do it this way, first of all. 1 over RT is equal to 1 over R1 plus 1 over R2. So it'll be 1 over 9 plus 1 over 18. The common denominator here is 18, because 18 goes into 18 and 9 goes into 18. So 9 goes into 18 twice. 2 times 1 is 2. 18 goes into 18 once. 1 times 1 is that. So I'm left with here with 3 over 18, which is really 1 over 6. So our total is really 6 over 1. So in other words, it's a 6 ohm resistor. So in other words, a 6 ohm resistor would have the same effect as a 9 ohm and an 80 ohm placed in parallel. Now I'm going to do it the other way this time, using the formula I gave you. So RT, I can see what you did, Kabir, okay, but watch what I do now. It is 9 times 18, okay? And it's 9 plus 18, okay? You had a 1 here, Kabiro, not a 9, okay? So it's a multiply 9 times 18. So I'm going to do this now, right? On my phone here. 9 times 18 equals 162. Divide it by 9 plus 18, which is 27. If I divide that by 27, I get 6 ohms. Matari, and come and look at yours now then, okay? Put it up again, Matari, I missed it. Put it up again, Matari, I missed it, sorry. Put your answer up. Matari, I missed it, sorry. Up again. Up, yeah, you got it. Fine, yeah. You had that answer. Yeah, good. Matari. I'm terrible with names, I'm terrible. Put your name on it. Matari, put your name on it, please. I can't say it. Yeah, your name? What's the name? Your name, the name, what's your name, Matari? Matari, what's your name? Moses. Thank you, Moses. Good. Thank you, Moses. Yeah. Okay. So let's move on a little bit with this now then. Okay, now I think you're getting there. Now I'm going to do this like we did last time. I'm going to do a network like this. Like that, okay? And I'm going to say all of these, right, are 6 ohm resistors. So I want to find one resistor that's the same effect as all these resistors together. Now then, I got to do this in stages. First of all, okay, I work out the equivalent resistance of that. So if you think of it, there's that 6 ohm resistor there. And then I've got an intermediate one here. I'm going to call R dash. So I want to find R dash first, because to go like this, RT, it'll just be R dash plus 6 ohms, will give me my total resistance. So R dash will be like this. 1 over R dash will be 1 over 6 plus 1 over 6, which in this case gives me 2 over 6, which is 1 over 3. So R dash is obviously 3 ohms. So this thing here is 3 ohms. So that thing there is 3 ohms. Yeah, I'm doing as an example, Emily. I'm doing as an example, okay? You just add them up. So 9 ohms, okay? So 9 ohms is the equivalent of all of that. So here's what we're given. We do the intermediate, and here is the answer. So I'm going to give you one to do now, okay, right? Think what I've done here. I worked out the parallel, and then I worked out the two in series. So I'm going to give you one to do now. I'll move off my board. Okay. So you can put this down now. There's a resistor there. And I'm going to say is 10 ohms. Resistor here, 10 ohms. Resistor there. So they're all 10 ohm resistances. And I want you to find one resistance that's the same effect of all those together. So you first of all work out the intermediate one that I call R dash, okay? So here's the diagram. There's the intermediate. Then you can work out the final answer, okay? So have a go at that now then, please, okay? I'll have a look. Mr. Marys, I'll look in a second. Bear with me. Okay, put it up again, please. Repeat. Yeah, go down a bit. Okay, right up. I'll go through it in a minute, and so Mary, bear with me for a second, okay? Waimuni, yeah. Well done, Margaret. Waimuni, that's right. Yes, well done, Margaret. I'll put it up again in a minute, so Mary's okay? I'll just wait for the others to give me see how they're getting on. Okay, Waimuni, I'm looking again. I can't see the name. Manga, yeah, that's right. Good. Yeah, manga. Yeah. Well done, manga. Yeah, you've obviously done a lot of this, so you're good at this, isn't it? Yeah, okay, good. We're building it up, we are, aren't we? Okay. Kabiro gonna show me an answer. I'm looking now. Oh, I can't see it. Yeah, that's right. Who is it? 15. Oh, who's that? Name, put a name on it, please. In Kabiro, can you put your name on it? I'll be there with you in a minute, Matari, okay? Thank you, Polycop. Thank you, Polycop. Yeah, good. Polycop, thanks. Matari. Yeah, look at you, man. I'm looking now. Yeah, that's right. Good. Yeah, good. Okay. I'm going to go through it now then, okay? So we have a network of resistors, all 10 ohms. And what we're going to do is find one resistor that has the same effect as those put together. These are resistances. So the first thing we do is work out the resistance of the combined network in parallel. So there's the 10 ohm one. So the first thing we do is work that. So that'll be 1 over R dash, be 1 over 10 plus 1 over 10, which is 2 over 10, which is 1 over 5. So R dash will be 5 over 1, will be 5 ohms. So this works out to be 5 ohms. Now these two are in series. So RT will be the 10 plus the 5 ohms, which gives me a of 15 ohms. In other words, a 15 ohm resistor has the same effect as those three 10 ohm resistors cut up like that. That's in series with that. Those two are in parallel. Okay, so we work that out first of all. Okay. So Mary's, are we okay? Right, I'm going to share my screen now then. And I should have a go at that. I want you to work out there, first of all, the total resistance of those. Work out the total resistance of that network. So have a go at that. Just working out RT first of all, okay? Now, those of you with me on Tuesday might be able to go a bit further. That's fine, don't worry. But start by doing the total resistance. So you're just working out, just as we've done just now, okay? We get the intermediate and then we add it to 3, isn't it? Okay? I'm going to put it on my board in a minute, though, okay? So don't worry if you don't get it down by the time I go to my board in a second. Okay, I'm gonna have a look now then. Okay, what's what answers we're getting up there? I see Mooney. Oh, work out the total resistance. Total resistance, okay? I can't see it. Yeah. Oh, hang on. Margaret, I can see what you've done. You've done, yeah, that's right. Margaret, you've done everything. Yeah, that's okay. That's right. Yeah, good. You've gone ahead of me. Good. Well done. You did that on Tuesday. Fine. That's okay. You've done more than the question. That's okay. I'll go through it in a second now. Well done. I want you to work out the total resistance of that network, okay? So it's a 3 ohm with a 6 ohm and a 3 ohm there. Yeah. Okay, I'm looking at Mooney. Give me a second again when I pin. Whoa, I can't. It's not quite clear there. You took it. Yeah, how do I say that name? Oh, crikey, Wab, Weber, Wabalello? Is it Wabalello? I can't say it. I can't. Hey, stop laughing. Stop laughing. It's me. Sorry. Okay, Matari. Let's have a look what you're doing, Matari. Sorry. I'm going to Matari now for a second. Bear with me, Matari. Let's have a look. Go put it up again, please, Matari. Put it up again. I can't quite see. Yeah, that's right. 2 ohms. Yeah, that's right. Moses. Good. Thank you, Moses. Good. 2 ohms. Good. Mooney, you're showing me something out or not? Thank you, Moses. That was good. Mooney, you're trying to show. Hang on. St. Mary's. Let's have a look then. St. Mary's. I'm coming up to St. Let me pin you. Yeah, 2 ohms. Good. That's right. Good. Well done. You got it now, haven't you? Yeah. Good. Good. Uh, who else was showing me that? Kabiro, are you okay? Kabiro, okay? No? Okay. I'll go through it now then. I'll go through it, okay? Right. So what I've got now is this network, isn't it? So I've got a resistor here, which offers 3 ohms worth of resistance. Then I've got these two here. In parallel, I've got a 6 ohm resistor there, and I've got a 3 ohm resistor there. So the first thing I do is work out the intermediate one here, which I've tended to call R dash. So I've got the 3 ohm there. So 1 over R dash is going to equal 1 over 6 plus 1 over 3. I bring it over a common denominator, which in this case is 6. 6 goes to 6 once. 1 times 1 is 1. 3 goes to 6 twice. 2 times 1 is 2. So what have I got there? I got 3 over 6, which is really 1 over 2. So R dash is equal to 2 ohms. Right, that is the R dash, isn't it? Okay. Now then, to find the final resistance, though, what are we doing? I'm adding R dash to it. So what I've got here is 5 ohms. The total resistance there of those two together is 5 ohms. So in other words, a 5 ohm resistor will replace that network and have the same effect. So let's just go to the question. Okay, that was the question. What I left in here, remember, was this 10 volts. So I'm going to put 10 volts there now. And we've just worked that out there to be 5 ohm. Now then, if I want to work out the current flowing this circuit, I will be V over R, which some of you have done, okay? So it's going to be 10 volts divided by 5 ohms, which gives me an answer of 2 amps. So the current flowing here is 2 amps. Back to the real circuit, that means there's 2 amps going along here. That means there's 2 amps going through that resistor. Now then, if that's the case then, I should be able to work out the voltage across that resistor by Ohm's law. V is I times R. So that voltage will be the current 2 multiplied by the resistance, which is 3. So what happens here? I've got 6 volts across. Right, so there's 6 volts there. Now then, they always add up to the total. So the voltage across this one will be 10 volts minus 6 volts, which is obviously going to be 4 volts. Right, what happens to the current when it gets here? Well, 2 amps comes to here. Some of it's going to go that way. Some of it's going to go that way. More is going to go down through the 3 ohm resistor than goes through the 6 ohm resistor. So I'm going to go up to here. Now, if I want to work out the current going through that 6 ohm resistor, it'll be the voltage across it divided by its resistance. The voltage across it is 4 volts. Its resistance is 6 ohms. So what's that? That's 2/3 of an amp, which is really 0.6666. So I'm going to call it 0.67 of an amp. So 2 amps comes in here, 0.67 of an amp goes through that. Now then, the rest goes through the 3 ohm. So the current flowing here will be 2 amps minus 0.67, which is 1.333. In other words, twice the amount of current down here. So the current going here is really 1.33 amps. More current goes through the least resistance. Less current goes through the more resistance. I'm going to do this now then, okay? Simulation, right? Okay? So we get everything clear. So I'm going to go there now then. Just to finish off with, I'm going to go to my simulation, putting those values in. I need to get rid of that. Okay, and that. So I'm now going to go to my simulation and do it here. Okay, so get rid of some of these, pin them. I'll start from scratch and draw the circuit. Although I want the resistances, I want resistor there anyway afterwards. I probably want the switch and that. Okay. So there's my switch, there's my resistor. Now my resistance there was 3 ohms. So I'm going to move this down a bit to make sure it's 3 ohms. One too far. Right, that is now 3 ohms. So I'm going to put a wire here. And I'm going to put a wire going up like that. And a wire going down, which will go to my bottom resistor. There. Put a wire here. So I'm going to get a resistor here. And the resistor there, right, was 6 ohms. So I'll make that 6 ohms. Okay, so that's now 6 ohms. I get another resistor now I put down here, which I'm going to make 3 ohms. 3 ohms. Okay. Now then, what I'm doing, I put an ammeter in here to measure the current flowing there. And I'm going to put an ammeter there, measure the current flowing through top resistor. So I'm trying to complete this circuit now, so I'm going to put that here. So it looks like the circuits we've been doing. And I have a wire coming down and going. So I have a wire going to there. So it does look a little bit like our circuit diagram. There's my wire. I'll move that to here. One more wire and I'm away. Okay, there's nothing on the ammeter at the moment. It was a 10-volt supply, wasn't it? So let's go to 10 volts. Right, I made that 10-volt supply. So when I switch on, I need to put an ammeter in the circuit here as well. So I'm going to put an ammeter there. So I move that to here. I need one more wire. And there's my circuit. So I got an ammeter measuring how much goes through the 3 ohm resistor. I got an ammeter to measure the current going through the 6 ohm resistor. I got an ammeter measuring the current here, which is what goes through this one. Switch on. I get the current going around like that. The total current is 2 amps. What did I say? It's 0.67 of an amp going through this resistor. So just put the values in there. Sorry. There we have the values. So that's the 3 ohm resistor. 6 ohm resistor. There's the 3 ohm resistor. 10-volt supply. So more current is going through the bottom resistor, 1.33 amps. When goes through that, plus that, it's up to 2 amps. So the current comes in here, 2 amps comes along like this. 0.67 goes through the 6 ohm resistor. Twice as much goes down here. Goes back together again here to form 2 amps. Now then, if I get the voltmeter and measure the voltage across this resistor, it's the 6 volts we did earlier. The voltage across that is 6 volts. Now then, if I measure the voltage resistor here, when I do it there, it'll be 4 volts. The 6 and the 4 adds up to the 10. Top resistor is 4 volts. So the 6 and the 4 is add up to the 10. And the current, whatever goes in there, comes out. Don't forget, mind you, each electrons are moving like that. You can see the blue electrons are moving quite quickly there. Not so quick going through those resistances. Okay, there's more current there, 2 amps, than there is in those two. Okay. I'm going to stop there now then for today on electricity. Can I ask St. Mary's, you mentioned Newton's laws of motion, St. Mary's. You want to do that as a topic next time? Is there something specific, okay? You mentioned Newton's laws of motion. You just show me what you mean in a minute, okay? And if oh, I have a look now. Okay. The topic. Okay. Thank you, St. Mary's. I'll do it as a topic. Yeah. Okay. Good. And I've added it to my list. Matari and Kabir, I asked for any topics you want me to do. Okay, right? I've had circular motion and I've had sound and waves. Okay. Circular motion. I'll look in a minute, St. Mary's. Stay with me a second, St. Mary's, okay? Sound and waves. Motion. Lenses as well, by the way. Linear motion, is it? Okay. Done linear motion, don't I? I've only just done linear motion. I'll add it, but we'll do it later, okay, right? Linear motion. Okay, St. Mary's, you were showing me something there. I didn't quite see it, sorry. Something. You want an assignment? What you want? Say a bit more there. What do you mean? You want an exercise to do or something? Or? An assignment on what? Sorry, I can't read that. Oh, wait, my money waves 1 and 2. Yeah, my money waves 1 and 2. Okay, we'll do waves 1 and 2. My money and I can't think what you're saying to me, St. Mary's. Are you writing it down, St. Mary's? Yeah, I am looking, but my money waves 1 and 2. I've seen that. Yeah, my money waves 1 and 2. Oh, hang on. Oh yeah, quantity of heat. Okay, hang on. The topic that we have done today. Oh, you want some more questions? Okay, got you. Okay. What I'll do, I'll email some questions. Okay, Michael will send them out to you. Okay, St. Mary's. I'll send Michael some questions. Okay, and quantity of heat. Do I mean yeah? Quantity of heat. Okay. I will put linear motion down, but we've only just done linear motion, I think, a bit, haven't we? Okay. And I'll come back to it. Okay. We'll stop there. I'll see you in 2 weeks. Okay. I can't teach next week. So I have done 2 lessons this week. Okay. So I'll see you 2 weeks today. When I'll finish off electricity, and I'll see which one I'll start on the topics. Okay. See you all again. Ta-ra. Thank you, Michael.
Thank you, Shaddai. Thank you.
I will send some questions so you can pass on to St. Mary's to have a go at, okay?
Okay, I'll do that.
Thank you, Mike. See you
Asante.
all. Ta-ra. Remember, you never walk alone because we're all Liverpool supporters. Yeah. Ta-ra. Ta-ra.